SIS, SSRS, and
Yes,
Power BI.
got it.
So now I want to transition my career to from Power BI to Azure Data Engineering.
Got it. Makes sense.
Yep.
Okay. Okay, cool. Thank you so much.
Yep.
And we have Gopal and Ram Reddy both. Hey
Yep.
Ram,
Hi.
hope you're doing good. And just at high level about your background, Gopal.
Hi, this is Gopal here. Mm,
Okay. Yeah, Gopal.
Yeah. Are you able to hear me?
Yes, I can hear
Okay.
you.
Yeah.
So your background at high level, very high level.
Yeah. Myself, Gopal, I'm having almost 17 plus years of experience in ETL background, means data stage informatica and
Okay.
and other kind of technologies like Python and
Mm-hmm.
worked in Snowflakes also. And
Okay.
currently, I'm looking for data Azure, Databricks and Azure data,
Engineering.
yeah, engineering.
Okay. 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 Thank you so much,
Mm.
Gopal. So Ram.
Hey, hi. This is Ram. So
Yeah.
I have around 12 years of experience, and
Mm-hmm.
also I'm the ETL. I know Snowflake, Azure, and this one. I'm looking for the data bricks. So where we will use most of the things.
I
Um,
see. Okay.
yep.
Okay. That makes sense. That makes sense. Okay. So just to give about myself, right? So just to have an introduction. So my name is Srinivas and I have nearly 20 plus years of IT experience and I come up with a combination of data engineering and data science. And I'm currently working as a senior cloud data architect in a multinational bank in UK. And most of my work related to the data building data engineering pipelines using Azure and then data stack like Databricks and Data Factory and Synapse. And also I use Snowflake. I'm using Snowflake since almost 2018. And I also work on some of the data science projects on top of the data pipelines, which I usually prepare. And coming to today's discussion, right? So this is we plan to give you a high level overview on what is data engineering and which you may have some basic idea, but I will try to give a, what is data engineering from my side, my understanding and my experience, and also I try to explain you like what are the different data stack services available in Azure side, and we'll try to see what are the each service is going to help in data building data pipelines, and we'll try to see that. Just let me share my screen. Please let me know you're able to see my screen. So here,
Yep.
so everybody here have some basic idea on what is data engineering. I'm just assuming, but just to understand data engineering, see, data engineering is not a new term, right? It was available since for a while, starting from the early 90s and 80s and 90s. Data engineering was people using, but that was majorly as a database engineering. So where people majorly was working on databases and people used to load the data and then manipulate it and they used to retrieve and the data used to help the companies to build their applications. And when you see the data engineering, so data engineering basically most of the data engineering projects in the market you see data ingestion is one of the very important step to capture the data. So the data may come from different sources. in the early stages, the data was only structured rows and columns, and people used to leverage that data, and the data analysis also was that very easy because we need to focus only on the structured data which is in the databases. And if you see, after 2010 and all, we got other types of data like formats also, like semi-structured we received. After big data came on the market, we also got quasi-structured data and unstructured data also. So these particular types of data, whatever available in the market, as a data engineer, I should be able to process any kind of data. Even if I receive a set of documents and I got requirement to process them, I should be able to do. Even if it is a voice, I need to do. If it is a video, I should be able to process. So, as a data engineer, our responsibility is to collect the data from different sources and try to load it or ingest it. And whenever you ingest this data, you need to ingest the raw data as it is. And once my raw data is loaded, and we will use that and we'll try to transform it into a desired form and finally push into the target data warehouse or data lake. So this particular data warehouse and data lake both are same, but there is a difference between data warehouse and data lake. When I say data warehouse, which will have the only historical data where you see, and this will be utilized for most of the dashboard development where people use. And coming to data lake, so data lake is also a location where your data will be centralized, but the data, any kind of data I can store in it, and even the volume of the data will be high, and varieties of data, and even the data low ingestion and the data processing and data extraction when you are performing on a data lake, they are very faster. And whatever you see, the raw data in most of the data engineering projects nowadays, people are following a architecture called Mendelian architecture. So when I say raw data, people call that as bronze layer data, and whenever we process it, that people call that as silver layer. And whenever you see the final data after you processed and you are ready to use it, that is people calling as golden layer. So this particular consumption, whatever you see, the last applications, data applications, or data science, and our people also use to the data which you finally centralized will be utilized in different ways. It will be dashboard development, or it may use for ML model development, or it can be data analysis and data science, or it also can be used for building data applications. So the data finally who will consume, that is very important. To bring the data into the form that is ready for the analysis or model predictions or dashboard development, all these require the final golden data source. So whatever the data pipelines you are building, the final objective is to convert the raw data into final processed data which is ready for utilization. So that is how every data engineering project is running in the market now, with ETL plus also ELT. So ETL usually will happen in the data warehousing environment, and where you will extract, transform, and load. That too specifically on the RDBMS kind of data. When I talk about ELT, this is basically will happen in the big data environments. Instead of transforming the data after you extract it, first you will load it and then you will go and transform. So the ELT is very popular now. And coming to most of the data engineering projects, if you see, if you observe here, the whenever you are building any data engineering projects, why we need to go for data engineering? That is also important, right? People have to understand why I need to go and build this data pipeline. What is the importance of the data? Why the company is looking for centralizing the data? So the data, whenever you go and try to centralize the data, there are so many reasons why people look for the data. Like as I mentioned, maybe the company wants to invest more on building ML applications, machine learning applications, or they want to go and utilize the data to build dashboards, or some people will use for analysis. So any data engineer project will have many people involved: data engineers, data scientists, business analysts, and this decision makers also will be there, and who will try to provide the final feedback. And we also will have few of the dashboard developers also will be available. So most of the data engineering projects, whatever running in the market, they need the data which is qualified data. The qualified data means
So sorry
whenever.
to interrupt.
Hmm.
This way, Madan, there was a 30 seconds mute while you have been speaking. Can you repeat the message? Just 30 seconds behind.
So the data quality is important. I mean, qualified. The qualified in the sense, whenever I go and build any data pipeline, I'm telling that the data should be reliable, right? Correct or not? When I'm building a dashboard means my data should be, the data quality is important. How can we ensure data quality? I need to see the data is cleaned or transformed to a form. For example, assume I have a data birth column. See, assume that the user is basically entering the age. In some people are entering in years, some people are entering in months, some people are giving date of birth, but that is not going to help me in my analysis, right? At the end of day, I need to transform that entire column into one single age column in years. And assume that I have a gender column. Some people entering my gender as either M or F for male and female. Some people are clearly they are entering full male and female. Some people giving MA and FA, something like that. So that is not also correct. So when people are entering in different ways, when you are loading the data, you also need to ensure that that is transformed, or it should, at least in the raw data, while loading, you have to cross check. And whatever data I received, at some level, the data should be having some qualified data. That is pretty much important. So one more important thing which we need to see, how efficiently you are running your data pipelines with scalability also. When I say scalability here, my data pipeline workflow should be able to run. Suddenly, if my data volume is increased, my pipeline should not be delayed. So data, whatever the volume or variety, I should have the same velocity also. So we should be not only able to create the pipelines, as a data engineer, I should be able to optimize the pipelines also. It can be ETL or ELT, whatever it is. I should be able to optimize the pipelines. And also the data, whatever I'm generating with my pipeline should be 100% utilized by the team, because we are spending so much effort to build these pipelines. So at the end of the day, the data should be utilized and I should get some business impact also. Then only there is a meaningful, like information will be circulated to the teams that the data is whatever generated going to help the teams. And coming to data, if you see, databases were there initially for online transaction processing, and then we got data warehouses for OLAP, and then we also got the data lakes also. So any idea the difference between data warehouse and data lake? Anyone? By any chance? Any one difference? Madan or Ram?
So data lake is nothing but we are not going to process the data. Initially, data will be dumped in the data lake,
Correct.
and whenever there is a requirement, we are going to write the programmatical queries and we are going to pull the data. And
Okay.
when it comes to data warehouse, it's totally historical data, like
Very
2
good.
years, 10 years,
Correct.
15 years of historical data will be stored, and it is all been processed. And when it comes to the
Data
that is
lake.
yeah,
So data
data lake,
lake, correct, you're right, 100% correct. So data lake and data warehouse, so both will store the data with the historical data, but data lake will also is going to capture not only structured, semi-structured, it can also capture unstructured data also, and also it can go with the big data. So big data and all, people call that as big data lake. So the data, whatever you are going to store in a big data lake, that is with high volume, with high velocity and different varieties also. So data lake is a centralized location which will be used to store huge amount of data, and that too how fast you are processing and how fast you are retrieving also. That is also important. So the data may come from, even for example, manufacturing plants will be continuously running IoT devices. The IoT devices will capture the mission status also, and they will be continuously sending messages. So this data should be captured as a live streaming data also. So data lake will have live data also, but data warehouse will not have the live data, right? Only historical data. Correct or not? My data warehouse means the name itself is saying which will store only historical data. It is mainly used for reporting. But coming to data lake, it can be used for even real-time applications also. Recommendation engines, which we usually see in the market now, and credit card fraud detection engine, money laundering detection engines. All these applications require live streaming data also. Why I need live streaming data for money laundering detection? I cannot go and say after 1 week there is a money laundering transaction. Correct, no? Can I say after 1 week there is a fraudulent credit card transaction in customer account? The customer will not accept, no? So immediately, whatever the transaction that has been more, whatever there are transactions, assume the credit card uh, is having some suspicious transactions, the suspicious transactions need to be immediately blocked. And the recommendation engines, when you go to any website like Amazon or any e-commerce websites, they will try to send you recommendations while buying the products. How do they know that you are interested in those products? So they will try to analyze your actions in their website, and those actions will be captured by the team, and they will try to see which products you selected and which pages you visited and whatever the navigation you performed. They will capture and they will try to see according to your actions in their website, they will try to recommend you the products. If I am interested in electronic, and they will recommend me electronic goods. If I go and buy a laptop, they will recommend me a charger or headphone. So according to the customer selection, the recommendation engine will react. So to implement such kind of recommendation engines, I need to use a data lake only. And coming to like the traditional ETL, if you see, you will have a set of sources, and you will also have a operational data store, and from there you will have a staging area, and then it will be moved to the data warehouse, and this data warehouse will be further divided into data marts to support the teams in a company, so that they will have their own dashboards and reports department wise, and that data will be usually accessible to users here. So each user maybe belongs to any one of this particular department here, the end users. So what these end users will do, they will perform the BI, the business intelligence part here. But this is the responsibility of the data engineers, correct or not? From here to here, the data engineers will be more involved in this particular ETL process here. And as soon as data is ready, the data engineers do not need to worry about the dashboard because BI team will be there. The dashboard team will take care of how to build the dashboards on the data which that has been generated using the ETL process. So the main core responsibility of any data engineer is data pipeline design and development, the first one. Second one, data integration and also data modeling. So data modeling also is one of the responsibility. I hope everybody know about what is data modeling. A data modeling, we have like dimension modeling, where we go and try to decide what are the different database objects we need. What are the tables, columns, what are the constraints, everything you do in the data modeling. Physical data modeling, logical data modeling, relational modeling. And if you go to data warehouse, you also need to know about star schema and snowflake schema also. And the third one, data warehouse development and storage and optimization also. If you have multiple data warehouses, you need to be able to manage them. And data quality and governance. Data quality here means when you are processing your data, after your data has been loaded, you should validate the data whether it is the right data or not, and the data quality also should be verified for the duplicates and null values. And we need to enforce the data integrity constraints. Data security mainly important. Like data masking you have to do. Data masking means you are going to mask your data. And coming to the next one, performance tuning and monitoring of your pipelines. And finally, collaboration and deployment of your pipelines. All this, whatever you see, these are the few of the data engineers roles and responsibilities. If you go to the market, you will follow all this, all whatever you see, all the 6 steps based on your project demand.
Sir, can you speak a bit more about performance, the fifth topic, the performance
The
tuning?
performance tuning, in the sense, sometimes what will happen, the pipeline will have some like slowness, and there might be some scalability issues, and health monitoring of the pipeline people do, right? See, when I'm running any pipeline orchestration, for example informatica, so you may schedule a job to run your transformations, right? Correct or not? So sometimes the jobs may be like suddenly may go and fail, and you need to monitor that also, right? It is not my that like that my job I is only building the pipelines. I should be able to troubleshoot the data issues if any, and performance bottlenecks also you have to see. If sometimes the report which is generating after my pipeline is executed, maybe it may have some dependency. The query performance example, the SQL queries which you may use also need to be optimized, and infrastructure need to be even scale up. I need to increase the infrastructure if needed. If it is a query a database level, for example, Snowflake level, how you will optimize? Anybody working on Snowflake here? How you will optimize your SQL queries? You can use the query acceleration service, and we also have like cluster keys which I can create, and so that my micro partitions can be eliminated, unnecessary micro partitions. So the performance optimization also important. The health monitoring of the pipelines, data issues you need to go and address. So every day may not be the same day, no? So you should be able to resolve some issues on a particular day if you receive. The query performance also need to be optimized. That is very important, because the query which is running fine yesterday may not run similar way today or tomorrow. So I should be able to perform a optimization or performance tuning. This can be at query level or a pipeline level or infrastructure level, that you have to cross check. If you go to Snowflake, why we increase the warehouse size? Because sometimes I need to see my query, single query may be running long. So what we do, what is the resolution to increase the query performance? We will increase the size of the warehouse from X small to medium or medium to large. And if it is single query, sometimes what happens, multiple users may be experiencing the latency. So which means that they need additional resources. So we will try to increase the number of clusters. So that will usually happen in Snowflake. Even for Databricks also same. The number of nodes you need to increase so that your pipelines will run faster than usual. Did I answer your question?
Yes,
Why
sir.
we need, yeah, the performance tuning and monitoring is very, very important,
Yes.
because most of the people will not focus on this fifth step, because they feel that their job is only building the pipelines. But a data engineer will do more than that. They will build the pipelines. They also perform the data modeling, and they manage the data warehouses, and they do the data quality checks also. DBT is one of the tool, very popular now. People are using that for data quality checks, and that is used for even transformations also. How many null values are there? We have to see. How many duplicate values are there? And how many rows were there in source and how many rows in the target? All these need to be performed. We should have a validation rule also. And data cleaning is required. So all should be, why if I don't clean the data, that may impact my dashboard and report. So I need to be very careful in that area. And these are some of the like different roles and responsibilities where data engineers are involved morely. Data architects are very, very huge demand in the market. And data engineers, some people build data engineering pipelines. And ops specialist, they basically will go and create the CI/CD pipelines and manage them. Data ops engineer, you might have heard about data ops, ML ops, AI ops in the market now. Everything is ops now. So data ops is also very popular now. Because majority of my pipelines, if you see, the pipelines will be scheduled, or there will be usually a CI/CD pipeline that will be continuously running, and whenever there is an issue, we will monitor the pipeline and we'll try to rectify it accordingly. And data steward, also very, very huge demand in the market now. So the data steward responsibility is to ensure the data governance and security. So if you go and see Snowflake, we have dynamic data masking, correct? So what data masking will help in Snowflake? It will give you column level masking and row level masking. So I can mask my data so that everybody will not see that. Only authorized people will able to see the columns. So data stewards are very, very popular now to maintain the data governance and security of the data. So coming to like example, if you take any particular, for example, healthcare application I need to build. So you see here the data may come from different sectors, right? In the same healthcare project, maybe public records may come from government databases, and there might be patient portals also will be there, where online access we give to a patient and they will log in and they will enter the data, and there will be some wearable devices to capture the health properties. So smartwatches, fitness trackers will help us. And coming to electronic health records of the patient, and clinics also generate some data, the OP, outpatient and visits and all, and pharmacy also like they will store some data, and finally laboratories also. So the diagnostic centers, they will also generate the lab results. So all these need to be stored, and they will come from in different ways. You see here, the patient data may come as a CSV file. Pharmacy data may come as a XML file. Labs may come from in JSON format. Again, clinical data may come from in some Excel file, and again research data from the lab may come from in CSV. So whatever the data you see, the data is coming in different sources in different file formats. But as a data engineer, our responsibility is to integrate all this and then consolidate the data and then push into the data warehouse and keep it ready for the analytics. So that is what, as a data engineer, we need to focus more. And if you see the market, that how the data is growing also, right? If as of now in 2026, you can see how the data is growing. So data keep on growing because of the social media. The social media is one of the biggest reason for high data growth. So they are generating billions of data every day. But how to maintain that, that is very difficult for the people also, because the internet users, smartphones, sensors, smart devices, IoT devices, everybody is generating the data. So that is causing mainly the big data also. Those are the drivers for big data. So why data is important? Because the data is very useful for decision making. So as a data engineer, I should feel that the data is very important for my project or company. And data will help us to understand the customer preferences, so that companies can improve their business also. And the data will give you the right direction to run the business. That is very important. And more data, more analysis, more results, and more profits. So always keep in mind that the data is going to give you some insights also, and data will increase the business value. That is why the high demand for data engineers and data scientists in the market. So whatever the analysis you perform, that analysis will give you a direction that the customer is interested in your products or not also. So we need to, as a data engineer, understand the importance of the data what you are going to centralize, because that is going to impact the company's business also. So this is some example of data cleaning. If you observe here, all the genders, if you see somewhere, M is there, male is there, and then MI is there, FEM, F female. So this is not standardized, correct? No, I need to standardize this data, means I will convert into a single value like this. All males will have M, and all females will have F here. So this is one of the cleaning process, data cleaning process. So where you will try to transform the inconsistent values into a standardized format, which is also called as data standardization too. And this is one example, and this is another example. So if see all the age column, I was talking about this, is not same. But if you see here, the data is correct now after I cleaned the data. Clear? So we are doing what we are doing here, data standardization we are doing here. where you are standardizing the age column. Sometimes you also will standardize the date columns also. So you will keep all the dates in the single format. So data standardization will help in that area. And this is where the data is coming from. Data is coming from multiple devices and multiple sectors, whatever you see, and most of the data is getting centralized in one location, and that is usually done by the data aggregators. So Nelson is a company which will do this process. Morningstar, WorldCheck, all these will collect the data and they will aggregate and they will centralize the data and they will even sell the data also. So all these medical sector, internet, retail, every domain is generating data. So we need to able to capture them and we need to see how to analyze them also. And coming to like data drivers, big data drivers, there are so many reasons where data is coming from, like diagnostic images, photos, video surveillance, many different ways. But all the data is categorized into four: structured, semi-structured, quasi-structured, and unstructured. Structured is nothing but CSV files. Semi-structured data means JSON and Parquet, XML, all will fall as semi-structured. And there are some quasi-structured data also, like clickstream data. When you click any website, your access will be tracked. That is where usually we call them as quasi-structured data. And finally, unstructured data, where you will try to upload videos, images, documents, and all this. So unstructured data is basically does not have any structure. And semi-structured data, which is basically you will have a data that particularly a JSON format or XML, this kind of data will be usually called as semi-structured data. And coming to like quasi-structured data, this is basically will be captured by every company as a clickstream data. So this clickstream data we have to see how to capture. So all this data, if at all I want to capture, I need to have a database to store, but databases may not going to help you to store all kinds of data because they are designed for only structured form. So to get into this particular data into our environment, you need to also have the dedicated infrastructure also. That is very important because data is increasing every day, day by day. And all these are some of the data generators. So in early 90s, my data was in terabytes only. And later when we moved to the 2000s, my data slowly moved to petabytes. And now you can see here, data is going to exabytes and zettabytes also. But who are generating this data? Majorly all the social media applications. And coming to global data growth, if you see the data is growing like anything. See 175 zettabytes of data is there, and by year you can see. So all this data I should be able to centralize and I should be able to leverage it whenever needed. The common challenges with any enterprise level on-premise servers is the maintenance cost will be increasing, and you also need a upfront expense to go and invest something we do not need to do if it is a cloud. But in normal traditional like database servers in on-premise, you need to pay upfront. Oracle license I need to buy if I want to use it. And any risk and data loss will be there. That will definitely happen only in the normal traditional databases. But coming to like cloud servers, you will not experience that kind of challenges because cloud is basically available anywhere using any device anytime. And sometimes what happens in on-premise, your company will have a limitation on the storage also. You don't want to use. And industry compliance policies also we should follow. Not every person will follow that. And coming to like IT support is also must. So when you go to any data engineering project, IT support also need to support the teams, because sometimes in some of the scenarios their presence also required. And performance hits, all these basically challenges with on-premise database servers. So we will rectify all this by using the cloud services, because that is pretty much important. If you go and see, when big data came into the market, every company started leveraging these many frameworks, and every framework, whatever you see, is very popular. And now some frameworks are not even available now. So all these were in the data journey. And coming to like the cloud computing, why people are moving to the cloud? So the cloud computing is giving a provision to access your data by using any like any device, anywhere, anytime. So that is where cloud computing is changing the world. And why people are going for cloud computing? Because it is cost effective, unlimited storage space, backup and recovery will be taken care by teams, and efficiency is one of the key factor, and flexibility, and then also faster deployment. These are what companies looking for. So when you are building any cloud computing environment and cloud databases, you also need to see all these factors. And coming to like cloud computing, what is cloud computing? All your infrastructure will be in the cloud, and you access with the internet connection. That is pretty much important. Internet connection is very important. And in on-premise, we'll see storage, servers, and then security, everything we need to go with like physically. But in normal cloud, everything will be in one place. Servers will be in the cloud, storage will be in the cloud, security also you will configure in the cloud side, and you also need a separate infra team also to manage all this. So these are the some challenges with on-premise data centers, and these are the cloud side how we can overcome those challenges. Pay as you go is basically with cloud services only, no upfront cost, and automatic software updates will be done by the teams. We do not need to do that in the on-premise side, or even cloud side also. You do not need to do that, and high flexibility to upgrade with few clicks. So here the flexibility which I mentioned with any cloud service is you can access your data from anywhere using any device anytime, and no additional staff is required to maintain the data center, since cloud service provider will maintain the data center. Plus data can be accessed through internet using a web portal. So if you go and see, most of the cloud services will be in the web portal only. Snowflake and platform, or database platform, or Azure portal, most of these particular tools are cloud environment. So we need to have some fundamental knowledge on the each cloud like Azure or AWS, and all the Azure specific database servers, virtual machines, all will be in the a cloud environment with a cloud account you have to create. Every cloud provider like Azure or AWS or GCP, they are running with a competition, and they are trying to see who is better in upcoming years. So Azure is a little bit popular now, and even it came late, it is slowly capturing the market along with AWS, and that is basically what a cloud computing and data engineering fundamentals. When you come and see for the Azure ecosystem, we have different services are there. Data Factory is one service, Data Bricks is another service, and Synapse Analytics one service. So if you see, Data Factory is basically used for data ingestion, and then data orchestration. And coming to like Databricks is basically used for processing the data, that is where data factory will provide. And then Synapse Analytics is another one where you will see the data warehouse and where you can go and use that as a data warehouse. So all these fall under Azure Data Services. And coming to like the cloud and on-premise, we already saw the differences. And Azure is basically very popular because of scalability, cost, and easily we can manage it. And finally, I can use the data for my A and ML development also. So that is how why people are moving to the Azure data engineering. And storage side, we have Azure Data Lake Storage, which is basically used for storing any kind of data. And we also have blob storage and like Azure Data Lake Storage Generation 2 to store the data. And we also need to think about the security and data protection also. So we have role-based access control and ACLs and firewalls to control the access. And any like particular data you want to store, you need to have a database. So Azure SQL database will help in that place. And serverless compute and hyperscale and relational. So Azure SQL database, which is in the cloud, is fully managed by Azure team, and which will have the relational features like normal traditional databases, and which is coming with the serverless feature, and it will store data, and it can scale up to 100 terabytes also. So all these are basically fall under Azure data services only. And we also have like services like Cosmos DB, similar to that, and we also have like uh, other the tools like Synapse Analytics. And whatever you see here, the storage account is blob storage, Azure machine learning is there, and SQL databases like SQL Server is there. And then all these particular services will help you to manage the end-to-end data pipelines. So resource groups and other I'll discuss later, but at high level, this is what majorly the data engineering means and how data engineering is going to help the data engineers to build the data pipelines. And the storage accounts is basically will store the data. And we also have like other services apart from this SQL databases and storage accounts. We also have Synapse Analytics and then Data Factory also. We should learn and understand about them as well. So we'll try to see them in the upcoming classes. And to perform the transformations after data is ingested, we need to know PySpark also. So PySpark with Databricks is one of the unique combination in the market now. So we should know both PySpark and as well as we also need to know a bit on Python, and then that we need to see how to build the data pipelines in the Databricks environment. We'll see that as well. But coming to like projects wise, if you see, there are so many like use cases which we are going to discuss. But this particular projects, if you see, this is data engineering end-to-end project, but specifically these are all the tools. And here this is the projects. The first project, supply chain project, where the data is coming from multiple different supply chain sources, and we are using data factory for loading the data. And once after my data is in Azure data data like generation 2, data factory can connect to the storage, and it can convert into a raw layer and then silver layer and gold layer. And once after data is available here, then we will process it. And who will help in processing? The Databricks service will help us to process the data which is stored in the like generation 2. And once after my data has been processed, then we will have a Synapse Analytics or Power BI or Azure will have. So supply chain is basically one of the unique domain, and where it will allow to send the product to the customer. And this is basically the banking specific. So what everybody like uh, uh, will go for their bank, and the data pipelines which we are going to see here, all these are the data input sources are coming from the different sources, and ATM, and also like point of sales, and this will help you to capture the data. But coming to unstructured data like mobile app logs, external market data, whatever the like sources coming, but at the end of the day we need to push into the final table. For that, where we use the other use case, and the third one e-commerce use case, and fourth one we also have manufacturing also. So manufacturing is also another like end-to-end project, and this is one of the architecture of the project, where we are using the ADF for data ingestion, and then data lake generation 2 for data like processing, and then we also have Synapse Analytics to connect to this particular gold layer and then generate the dashboards with Power BI. Clear? Any questions? And what are the prerequisites? I should know at least some fundamental SQL and Python, and we are going to learn on how to build the data pipelines by leveraging this particular SQL and Python and other like features, and we should be able to build the ETL pipelines for various business, and we also need to have a knowledge to learn most of these tools in deeper. That is very important, and you also should get some cloud knowledge as well, which will help to run your data pipelines faster without any errors. So any other questions from
Sir,
you?
Madan here.
Yes,
So
Madan.
when it comes to Python, any specific topics that you would like to address in the call, sir? Like,
Very good question. Yeah. So we will try to go with the basic Python and some part of advanced Python like pandas and NumPy, because PySpark also have data frames concept. The same concept is available in Python as pandas data frames. So if you learn in Python specifically, that will be sometimes you will convert pandas data frames to PySpark data frames also. So we should know how to process the data using pandas data frames. At the same time, PySpark data frames also. I'll cover Python whatever is needed to understand PySpark. Hope that is clear. Because PySpark also a combination of Python and Spark, right? Correct or not? So you should know some basic Python coding. I will try to teach that, don't worry. We will learn some Python with some Python classes also. Is it clear, Madan?
yes, sir.
Yeah. Any like tools we are going to learn, we will try to learn them, and we also will learn the prerequisites as well. I hope everybody is familiar with SQL here. Correct, no? Or do people, anybody does not know SQL here?
Everyone knows. I think.
No, right? So that's what I'm saying. So SQL is not important here, because SQL is basically is a database language, so everybody knows it. But Python may not be. So Python is one of the like general purpose programming language. But I'm going to cover Python. I'm going to teach you with Python, and then I also will go and try to discuss about PySpark and Databricks along with all the data services like ADF. We also will learn about data lake generation too, and then Databricks, And we also will try to learn about Synapse and then Power BI as well. All this. And we'll try to integrate them with a few end-to-end projects also at the end of the training. And you will have a daily assignments, daily recordings, daily hands-on scripts if required. And along with that, you also will try to learn with use case, not like only what is what. That is how you have to learn. Correct or not? You have to learn with use case. Is correct or not, my question? Do you agree, all of you?
Yep.
So we will learn with use case. What is the purpose? When to use it? And we'll try to implement some use cases so that you will get some clarity on how to use it. Why I need to do standardization in silver layer? And what are the standardization rules? When I will go and apply some transformations? What kind of transformations? What kind of data quality checks we have to perform? All we will learn one by one. Clear?
Yeah.
So that's all I want to cover today. And coming to like course curriculum, I think Dia might have already shared you what we are going to cover. So we are going to cover, let me show you that. So we are going to like learn like the basic fundamentals, because data warehousing fundamentals is needed. I will try to cover that. And SQL, usually that's I hope everybody knows SQL, so I may skip that because SQL is already most of the people are familiar here. And then we also will learn about Python. And once you learn Python with basic Python and advanced Python, then we'll move to the Azure basics. And we also will try to understand about what are the different Azure data services available and their importance in building the data pipelines. And when you are working in any data engineering projects, especially in Azure, we should know specifically what are the cloud services available and how to access, create a database in the cloud and how to access it, and what are the different ways to create the SQL Server database. We'll see that. And then Azure storage, like we have block storage, we have like data lake generation too. We'll try to learn about both one by one. And once you finish that, then we'll move to the data factory for data ingestion and also applying some transformations if needed, and how to create data factory pipelines, and how to understand different components of the data factory like pipelines, linked services, and data sets, activities, triggers. So all we will understand here. And this is one of the very important service for any data engineer in data factory. And as soon as you finish that, you will move to the Databricks. So Databricks is basically used to perform the transformations. And then we will try to learn about PySpark with Databricks end to end. And we also will learn how to build some basic pipelines by using Databricks. And finally, once my data is processed and transformed in Databricks, I'll move to that Synapse Analytics for building the data warehouse, which is here we will try to discuss about the star schema, snowflake schema, and how to build a data model also here. And once after you understood that, you also need to understand what is data lake house also, and how Synapse Analytics can help us in that area. And we'll try to see how to leverage our Spark knowledge also here to understand about Spark pools and all this. And we'll try to learn about Synapse Analytics, end-to-end Synapse Analytics here. And we also need to understand how to go and integrate with Power BI as well. So we'll try to even learn how to integrate this final golden source with pipeline results to Power BI, and we'll try to see some dashboard development as well. And you will receive most of the daily recordings, assignments, hands-on scripts, everything through Google Drive. And also I'll try to share some interview questions and sample series also for your reference. This is what usually We are just planning. Any questions? Gopal?
Sri, what is the course duration for this entire course structure?
40 to 45 days. 45 days, including the projects.
You can say like 1.5 months entire it will take the
Correct.
month-wise duration. Yeah.
Yeah, is correct. Yeah, is right. Any questions? Ram, from your side?
No, it's good. And I just want one more thing. So in the process, right? See, the data breaks and this one is just processing data, or
See, processing in the sense, it is not like just you will go and ingest the data, right? You apply many different transformations also, no?
yeah. Because
So
I am the Snowflake developer that process and ELT, ETL, everything. I
mm,
just
mm,
want to
mm,
know what is the purpose, because Snowflake also will pass pipelines, everything. But
mm.
Databricks and Snowflake, what's the difference? Little bit. This
See,
time on.
majorly, say both are different platforms, right? See, Databricks is a platform where it will allow you to create your transformations using PySpark, and you will try to create your data pipeline with different tasks, and each task will be a Python notebook here. Jupyter notebook will try to configure, and Databricks will come with a cluster environment, right? You need to create a Databricks cluster, compute cluster. But in Snowflake, you will have a virtual warehouse, correct or not?
Yes, that's
But a virtual warehouse basically is a group of clusters again. I can create a 300 cluster warehouse also, correct or not?
okay, got it. This is cluster based, so okay. Okay,
So
yeah, got it.
the compute is very important both sides. Without
Okay,
compute, the processing will not be that much faster, no?
yeah, got it. Now got it.
Yeah,
Thank you.
even I work on Snowflake projects. I compare. I do some kind comparative analysis also.
Yeah, yes,
So we have to do right most of the
yeah,
projects.
yes. Okay, got
Even
it.
even now in LinkedIn there is a big war running, right, between Databricks and Snowflake.
Yeah, that's why I asked this one. See, now they are telling this one because anywhere you are going, end of the day, the pipelines and this thing. So
True,
that's why
true,
they are
true.
fighting. Same thing.
That,
Okay, good.
see, whoever working in the company, they have to support their company, no?
Yeah, got it.
If someone
Okay.
is saying Databricks is not good, means
Yeah.
when he
Okay.
joins in Databricks, then he'll come to know.
Yeah.
So that's what. So usually, like, see, it depends upon the scenario, right? We cannot say that Databricks is great or
Yeah. Yeah.
Snowflake is great according to your project demand and
Yeah, budget and all
ah,
everything will be involved.
the
Yes.
situation.
Yes. Got it.
That
Got
is
it.
people have to realize that fact
Yes. Yeah. Okay. Thank you.
at the end of
Thanks.
it. Okay, then yeah. So any specific other questions if you have, we
Sir,
can reach out via. Yeah,
yeah,
please go
Madan
ahead.
here.
Sorry.
So when we just now, as my fellow partner, he just took a topic regarding Databricks and Snowflakes. Snowflakes
Mm,
is more of into SQL kind of a thing, is what I heard about in some of
mm.
the articles. So when it
Correct.
comes to Databricks, what would you say, sir? Because I'm little unclear with the Databricks part. Snowflakes, I
See,
have understood that it is
Databricks.
more of a SQL,
Uh,
like. It's an
Correct.
advanced version SQL kind of a thing where, as you
Agree.
said, masking of rows and column wise, we can
Agree.
do it in Snowflakes.
So Databricks, right? Databricks is totally built on Spark platform, right?
Correct.
So the
They are the
compute
all
is
the leading
mm,
who had worked in Apache Spark only. They have built the
majorly.
Databricks company. Yeah,
Exactly. Correct. So most of the platform is optimized using Spark, Scala and Spark.
correct.
So when you see in Databricks, right, majorly they focus on the data pipelines that too in PySpark now. Even
Okay.
people use Scala also, but majority nowadays they are using PySpark. But
Okay.
at the end of day, as a data engineer, your job is not simply create the pipelines. You also need to have the knowledge on how to create a cluster and how to select the best configuration for a cluster. You should know, right? Correct or not?
Correct.
So all these you have to focus more. And at the same time, you should support the data science teams also, because Databricks platform for not only for data engineering, it is for data science projects also. There is separate tab for data science and data engineering, right? Correct or not?
Correct.
So I should support data science teams if needed, and the end-to-end data pipelines, how to orchestrate them. We need to learn throughout the training. Okay.
Okay, sir. Okay.
Okay then. Yeah. Okay. That's all for today. Yeah, that's all from my side. Okay.
Sure.
Okay, anything else? Just please check with the team and you can come back to me.
Yeah, sure. Thank you so much, Srinivasa, for the demo session today.
Okay.
Learner, if any questions and doubts you're having, the technical one, again, you can ask Srinivasa, and relates to the classes and any timings part, you can talk to me for that particular thing.
Yeah, Divya. So we'll let you know. We'll message you. So once we check with our time,
Yeah,
and we'll let you
definitely.
know that.
Yeah. I will
Yeah.
connect with you like after the demo session. Okay.
Yeah. Thanks.
Thank
Thank
you.
you so much.
Thank you, team. Yeah, thank you. No problem.
Yeah.
Thank you so much, guys. Have a good day.
Have a good
Good
day.
night to
Bye.
you.
Good night.
Yeah.
Yeah.
Thank
Good
you.
night.